So the next aspect of qualitative analysis is determination of functional group. Now we have done call it what? The what? Determination of what? Functional group. This determination of functional group, you can also call it what? Text for what? Functional group. So we have what we call what? Group, text, and a positive result. So let me start from tabulate form. Let me tabulate it in this form. Here we have what? Group. This is for what? Group. Here we have so let's say so this place is what we call what? Group. Here we have text for functional group. This place will be what? Positive result. So here now, so let us start from the first family or group of organic what? Compounds, which is known as what? Saturated hydro what? Hydrocarbon. You know, for the saturated hydrocarbon, the compound is a organic compound with carbon to carbon, carbon, carbon to carbon to carbon single bonds. But the text for saturated hydrocarbon, the common text for it is combustion. Combustion what? Reaction. When saturated hydrocarbon undergo combustion reaction, what do we have in the what? In the what do we have in the result? The result here will be what? A blue or a clear yellow flame. Observe. Whenever you are burn organic compound in what? Here. And the flame even is not smoky, is a blue flame. The presence of the blue flame during combustion reaction of what? Of saturated hydrocarbon is tell us that what? The compound is what? Alkane. The compound there will be what? Alkane. Which is what? Saturated hydrocarbon. And the next family we are going to test for functional group is unsaturated hydrocarbon. Unsaturated hydrocarbon. The unsaturated hydrocarbon, you know, we have hydrocarbon is a compound that we have carbon-carbon double bond. If it have carbon-carbon what? Double bond. The compound is called what? Alkene. So if it is has what? Carbon-carbon triple bond like this, the compound is what? Alkyne. So how are we going to what? To test for these two functional groups. The first test that we use is combustion what? Reaction. If you burn them in what? In air, combustion, we will have a what? A smoky flame. A what? A smoky flame if it is observed. The compound present is what? Is unsaturated hydrocarbon. So whenever we are burning saturated hydrocarbon and we have a smoky flame, the compound is what? Is alkene or what? Alkyne. And the second reagent that we can use is addition of bromine in 1,1,1 trichloromethane. So when bromine in 1,1,1 trichloromethane is being added to unsaturated hydrocarbon, the color of this bromine is brown. So when it's being reacted with what? Unsaturated hydrocarbon, it will decolorize. Decolorization occur. That is, it change the brown color of bromine to what? To colorless. So the first test for saturated hydrocarbon and unsaturated hydrocarbon is combustion. Whenever you are burning organic compound in what? In air, you have a smoky flame. To tell you that what? Is saturated, either alkene or alkyne. But if it give you a fine yellow flame or a blue flame, is what? Is saturated, which is what? Alkene. But or if organic compound hydrocarbon is react with bromine water, which is what? Bromine in 1,1,1 trichloromethane, the color of this reagent is brown. Whenever it reacts with what? Unsaturated, it will change the color to colorless. Call it what? Decolorization. And the second one that you can also use what? Addition of KMNO4. Addition of what? Addition of KM what? NO4. Addition of KMNO4. This KMNO4 is purple color. So when the KMNO4 is being reacted with what? Alkene and alkyne, which is unsaturated, the colorization also occur. Colorization also what? Occur. The colorization of what? Of KMNO4 is also what? Occur. That is, it changed the KMNO4 from purple to what? To colorless. change it from purple to what? To colorless. So let me just stop with these three. To test for saturated combustion, you have a smoky flame. Saturated, addition with bromine water, bromine in 111, trichloromethane. The color of this reagent, which is brown, change to colorless because of decolorization. If you add what KMNO4, which is purple, to either alkene or alkyne, it will change the color to colorless. Purple alcohol what? Decolorization. The next one is what? Test for halide. Halide, what is halide? Is R this. The functional group here is what? The functional group here is what? Is X. And we know that what this X, it may be chlorine, bromine, and iodide. We have done it in what? In a sodium fusion test. So in this place now, what the reagent we use what? Hydrolysis of AgNO3, not in what? Acidic, which is what? Plus HNO3. If you add it to this, you know that what? A precipitate is what? Will form. Abi? Precipitate, form. And this precipitate that is what? That is formed here, if it is what? Precipitate is white. If precipitate is what? Is white. If white what? PPT form. The halide there is chlorine. But if a what? A pale yellow PPT form, the chloride there will be what? Bromine. But if a yellow PPT form, the halide there, not chloride, halide there will be what? Iodide. So that is what? Test for halide. So to test for halide, which reagent are we use? Is AgNO3 and HNO3. Precipitate form, if precipitate is white precipitate, chlorine present. If pale yellow is bromine. If yellow precipitate is iodide formed. The next one is alkanol. Alka what? Which is ROH. And the functional group here for alkanol is what? Is OH. What is the reagent used for the alkanol? We can use what? The first one, we can use metal addition of sodium metal with what? With alkanol. At the product side here, we have evolution of hydrogen gas. There will be what? Evolution of what? Hydrogen gas. So whenever the sodium metal reacts with what? Alkanol, we have what? The effervescence of, or the evolution of what? Of hydrogen gas with what? Will be liberates. Test for alkanol. If you are using hydrogen, sodium metal, it will liberate hydrogen gas. Number two, we can use what? Oxidation of alkanol by KMNO4. As what? Oxidation alkanol by into K2 Cr2 O7 potassium dichromate. So what will happen here? The alkanol will change. The color of this one is what? Is orange, and we change it to what? To green. Change from what? Orange to what? To green. Change from what? From orange to what? To green. And the next one, you can, if the oxidation of alkanol by K2Cr2O7, the color of this man is what? Is green. It's orange. And whenever it reacts with what? With alkanol, it will give us what? Green. And you know that what? The oxidation of alkanol can exist in in two forms. We have oxidation of primary alkanol will give us alkana. So the second stage, alkana will give us what? Alkanoic acid. So we get there. We should get there. So when you oxidize alkanol now, know that what? It will change by KMNO4, K2Cr2O7. The color of this one is orange, and it will change to what? It will change to uh, green. And the next one is test for alkanol by using Lucas reagent. By using what? Lucas what? Reagent. Lucas reagent. Lucas reagent is a reagent that is made up of zinc chloride plus HCl. And this Lucas reagent is a reagent that we use to differentiate between primary, secondary, and tertiary alkanol. No, the alkanol can be grouped into three. Let me little bit deviate. If we have alkanol like this, can be grouped into three. We have primary, we have secondary, and we have tertiary. So the primary alkanol is, example of primary alkanol is this. We can have what? COH, R, H, H. But for secondary, CH, R, OH. For tertiary, we have R, 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 O what? OH. You can see that what? For this primary here, the carbon atom that is carry this OH contain how many alkyl group? One. That's why we call it primary alkanol. Here, the carbon atom that is carry this what? OH contain how many R? This R means what? Alkyl group. The R is what? Alkyl what? R alkyl group is what? Is R. So this, how many alkyl group we have in this carbon atom that contain OH? Two. That's why we call it what? Secondary alkanol. The carbon atom that carry OH here contain how many alkyl group? Three. One, two, three. So that's why we call it what? Tertiary alkanol. So if you oxidize primary alkanol, it will give you what? Secondary alkanol. Oxidation of secondary alkanol will give us what? Tertiary alkanol. So, and how are we going to what? To distinguish between primary, secondary, and tertiary alkanol? If we now use what? A reagent called Lucas. Called what? Lucas reagent. So when Lucas reagent reacts with alkanol, under your result here, there will be what? Time for separation. Time for what? Separation of the layers. So the time for separation of two layers is the positive test for the Lucas reagent of alkanol. And it is the immediate separation with tertiary alkanol. It will take 5 to 10 minutes for secondary, where it's up to an hour for primary. Let me extend my table here. Yes. Then we have group. We have what? Group. Kinase compounds. Here we have what? Test. And here we have positive results. So in the group here, no, we are still on Aka what? Alkanol. Abi? Okay, what is the test for Alkanol? We are still using what? Lucas reagent. So if you add Lucas reagent with alkanol, times for the what? Time for separation of the layers. So, and the separation of the layer, it should be what? Immediate. Immediate separation should be what? It is the immediate separation for tertiary alkanol. But it is 5 to 10 minutes for secondary alkanol. But it is an hour for primary alkanol. We are still on the Lucas what? Lucas reagent. So the reagent we use here is what? Is Lucas. So we put what? Lucas reagent, which is combination of what? Zinc chloride is what? HCl, is used to differentiate between primary, secondary, and tertiary alkanol. So the family here is alka what? Alkanol, which is functional group is OH. This is general formula for the alkanol. So the time for separation, if this Lucas reagent will react with what? Lucas reagent. For the tertiary alkanol, the layers will separate immediately. For the secondary alkanol, it will take 5 to 10 minutes to work for separation of the layer. For the primary alkanol, is more than an hour to work for separation. And the next one that we need for the other alkanol is hydroform test. Hydroform. Talk about hydroform test. Hydroform test for alkanol. The hydroform reagent is the reagent of iodine gas and sodium hydroxide. So when it reacts with alkanol, we have formation of fine yellow crystal, of fine yellow crystal, which is what? CH3. So that is all about the test for what? Alkanol. Yeah, sodium metal, oxidation by K2Cl2O7, Lucas reagent, and hydroform. Those are the four reagents that you can use to test for alkanol. The next one is aldehyde. Aldehyde, we can also call it what? Alkanal. Alka what? Alkanal. This is a functional group COH. And to test for the alkanal, we can use what? Addition of sodium hydrogen sulfate. Addition of sodium hydrogen sulfate to the alkanal. Under your observation here, we have formation of crystalline salts. What? Salt. So when sodium hydrogen sulfide react with what? Alkaline, we have what? Formation of what? Of crystalline what? Salt. The next reagent that we can also use here is addition of 2,4-dinitrophenylhydrazine. Addition of what? Of 2,4-dinitrophenylhydrazine. If this react with alkanal or aldehyde, we have a formation of yellow-orange precipitate. We have what? Formation of yellow-orange PPT. So is the addition of 2,4-dinitrophenylhydrazine with aldehyde, we have a fine yellow-orange precipitate. The next one is what? A silver mirror test. Silver mirror test. The silver mirror test, we can also call it what? Toluene. We can also call it what? Toluene reagent. Toluene what? Reagent. What is toluene reagent? Is a reagent that is comprised of Ag, NO3, and excess ammonia and excess ammonia. That's toluene reagent. When a toluene reagent reacts with what? Aldehyde, is a silver mirror test. Formation of a layer of a silver on the surface of the test tube will form. We have forming what? Formation of a layer of what? Of a layer of silver on the surface of the test tube. So this is what we call what? Silver mirror test. After that, we can also use a Ferlin test. The what? Ferlin test. Ferlin test. This Ferlin test also contains Ferlin what? Reagent. Ferlin what? Reagent. When the Ferlin reagent react with alkana, there will be a what? Formation of red precipitate. There will be the what? Formation of red PPT, which is what? Copper oxide. So, for the aldehyde, we have this. To test for aldehyde, sodium hydrogen sulfate, formation of crystalline salt, 2,4-dinitrophenylhydrazine, give us what? Yellow-orange precipitate. With sliver mirror test, aldehyde or alkana, we have formation of what? Of layer of sliver and surface of the what? Of the test tube. With Ferlin, we have a red or brick red precipitate. And the last one, we can also have what? Iodoform test. Iodoform test. The iodoform test here is the same thing with the one we have in the alkanol, which is I, sodium hydroxide. It will have the same observation, formation of fine yellow crystal. See, the iodoform test for aldehyde, ketone, and alkanol, they have the same positive what? The same positive results. They have the same positive what? Results. So these are the necessary 5 reagents that we can use to test for the what? For the aldehyde in any exam. So by using what? Sodium hydrogen sulfate or 2,4-dinitrophenylhydrazine or a sliver mirror test or a Ferlin reagent or by using iodoform. So the next one is what we called what? Ketone. The next group is what? Ketone. And this ketone, or we can also call it what? Alkanone. And the functional group for alkanone is this or this. And this alkanone, it undergo iodoform test. Let me start from here. Yeah. Number 1, addition. See, let me mark it out. These 3 reactions, this 1, 2, and this, they can be found in alkanone. The 2 reagents that you can use to derive between alkanone and alkana is what? Is the Ferlin test and the sliver mirror test. These 2 reactions can use to what? Derive between aldehyde and ketone. Because this ketone give positive results with this one, this, and this. Give negative with these 2. So let's go now. The addition of sodium hydrogen sulfate here, you will observe that what? We have formation of crystalline salt. And the next one is what next? Addition of 2,4-dinitrophenylhydrazine. So we also have what? Formation of a yellow orange PPT. I said it before that this ketone also gives a positive result with these two three. The last one, let me use hydroform. Hydroform test. It will give you what? Formation of fine yellow crystal. You can now see that what? Ketone give positive result with 1, 2, 3. So we can use Ferlin reagent and a toluene reagent to differentiate between aldehyde and ketone, because the only aldehyde that give positive result with what? Toluene and Ferlin, but this ketone is give what? Negative result with these two. So remaining others. So the next organic group or family now is ester. Ester, you can also call it what? Alkanoids. Call it what? What? Alkanoids. Call it what? What? Alkanoids or ester. And the functional group is CO O dish. So it will be Aki. This is Aki. This is all called what? Ester. The alkanoids. The alkanoids, there is no specific test for the what? For the ester family. We can just use what? The smell, the alkalinity smell, which is what? A fruit smell, to observe them. So what? No specific text, but it can be distinguished. It can be what? Distinguished by its smell. Yes. By its what? Its smell. What kind of smell? The smell is what? A sweet and fruit smell. That's for the what? Ester. So the next organic family, it will be carboxylic acid. Carbo what? Carboxylic acid. So the next family now is carboxylic acid. Or alkanoic acid. And the general formula for the alkanoic acid is COOH. That's the functional group for the alkanoic acid. And to test for the alkanoic acid, we can use what? Litmus test. Litmus. Use what? Litmus test. So the alkanoic acid is an acid and is what? Turn or change blue litmus to red. So the litmus test is what? Because it's an acidic, it will change what? Blue litmus to what? To red. And the next one, under carboxylic acid, the addition of sodium metal to any one of the family of carboxylic acid, there will be the what? The evolution or liberation of what? Of hydrogen. Because it's what is acidic. This hydrogen will be what? Will be liberate. And I say what? Addition, addi what? Addition of sodium. There will be the what? Evolution of hydrogen gas, which is give what? Form sand. We have this. And the next one, you can also use what? The addition of sodium hydrogen carbonate. You know, when any carbonate salt react with acid, there will be the what? The effervescence of CO2, which change what? Lime water making. So here too, you can also have what? If you add addition of sodium hydrogen carbonate salts into the what? Carboxylic acid family, there will be an what? Evolution of hydrogen, evolution of carbon oxide, which what? Turn lime water milky. So the last test of carboxylic acid is if you use what? Call it ester formation. We call it ester what? Formation. Ester formation. It is formation of ester. If the take what? Alkanol in the presence of what? Of cork H2SO4, when it reacts with carboxylic acid, it will give us what? Ester and water. And the process is called esterification. Can I say what? Absolute alcohol, it was Alkanol and cork H2SO4. So here there will be a what? A formation of a sweet fruit, a sweet fruity smell of an ester. So when alkanol reacts with carboxylic acid in the presence of H2SO4, there will be a what? A sweet fruit smell of what? Of an ester. That's what we have. So that is all about the what? The test for carboxylic acid. Litmus test. Addition of sodium metal, carbonate salt, and alkanol salt. The next one that I would like to treat now is amine. If you are talking about amine, you can also call it what? Alkan amine. Call it what? Alkan amine. And the functional group for this family is NH2. So the amine, the test for amine can be achieved by isocyan test. Isocyanide what? Test, which comprise of CHCl3 in the presence of sodium hydroxide. So this test is for primary what? amine. And then what do you have in your results? There will be the what? Formation of isocyanate, formation of what? Isocyanate with four small. And we can also use what? Diazonium salt, which is give us the what? The evolution of what? Of nitrogen. So use what? Diazonium, write it in this form, azonium salt formation. Here we have evolution of nitrogen what? Gas. You can also use what? Naphthalene 2-O. If amine is what? Phenylamine. If our amine is an hydrocarbon in this form, we have it in this. So in order to test for it, we use what? Now what? Naphthalene. 2-O. This test is for what? Phenyl what? Amine, and a result will be formation of orange or red precipitate. That is for what? A what? Amine. And the last one is amide. What happened to amide? Amide, we can also call it what? Alkan amide. Amide is MIN. Amide is what? MIDE. They are different. And the functional group for this amide is a carboxylic acid derivative. Here is N2 alone. It's carbonyl N2 amide. So for the amide, it's hydrolysis with sodium hydroxide under reflux. And there will be the what? The formation of what? Of ammonia gas. So if we hydrolyze, call it what? Hydrolysis with sodium hydroxide under reflux. There will be the what? Evolution of ammonia gas. So let me add one compound which is known as what? As ether. Ether. Ether differ from ester. Ester. Ether is known as what? Oxy alkane. This is a functional group. So this ether also have what? No specific tests for ether. No specific test for ether, but they are always soluble in Cork A2SO4. But they are soluble in Cork H2SO4. So that is all about the what? The test for functional group we have in organic chemistry.